This video is going to focus on changes and properties of substances. We're going to start by reviewing elements, compounds, and mixtures. So elements, again, are one of your two types of pure substances. They are made of the same kinds of atoms. The atoms will have the same number of protons. They don't necessarily have to have the same number of neutrons. They cannot be broken down any further by either physical or chemical means into something simpler. So examples would be nitrogen, calcium, arsenic, any of the elements on your periodic table. It does not matter if they exist in atomic form or if they exist as atoms combined together to form a molecule, like with nitrogen or with the tetraatomic arsenic. As long as there's one capital letter, you only have one element present. Compounds are another type of pure substance, but they are made of two or more different elements. So nitrogen would not be classified as a compound. You have to have two different elements chemically combined together. These cannot be broken down physically, but they can be broken down chemically via decomposition reactions into simpler compounds or even into their representative elements. There are some examples of your compounds. You will notice with all three of those compounds, they all have two or more unique capital letters representing two or more unique elements. Finally, with mixtures, what makes elements and compounds considered to be pure substances as opposed to mixtures is that no matter where, what part of the sample you take for that element or you take for that compound is going to have the same composition. Mixtures, however, that is not necessarily the case. It is rarely the case, actually, for that to take place. They have variable composition because they are made of two or more pure substances, and they can be separated by physical means, by phase changes, by using your senses, using your fans, by using evaporation, strainers. There's lots of different ways that mixtures can be broken down into the substances that were used to form them. You can have both homogeneous and you can have heterogeneous mixtures. So there are some examples of mixtures: wood, milk, and coffee. When you see the letters AQ after a chemical substance, that is indeed a mixture. It is a homogeneous solution because something has been added to water. So with physical and chemical changes, physical changes are not going to result in the new substance being formed. You may change the form of the substance you started with, but you will not change the identity of that substance. So phase changes aren't going to change what was making it up. Tearing something apart, crushing something, dissolving salt and water. You still have the salt, you still have the water. Chemical changes, however, do result in something new being formed. That you are able to react with acids, that you are able to react with oxygen, that you can go through combustion, that photosynthesis takes place. Those are all changes that occur that result in new chemical substances being formed that have unique properties that distinguish them from where they came. So first example, sorry, I clicked too fast, melting iron metal. You're changing iron from a solid to a liquid. That's still going to be iron, and therefore it would be a physical change. Whereas in the second example, you're taking iron and combining it with oxygen to make rust, Fe2O3. So you're taking two elements and combining them together to make a new compound. That is an example of something new forming and would be a chemical change. In example 3, we have dry ice. CO2 is a solid that is had heat applied to it to allow it to become a gas. It's still CO2, it's just changed its form. So that is an example of a physical change. When wood is burned, you cannot get that wood back. You have produced carbon dioxide along with water and other trace gases that have formed from the impure combustion or incomplete combustion. That would be an example of a chemical change. One of the demonstrations I like to do with my students at the beginning of each year is elephant toothpaste. And if you had Mr. Hopenhaver last year, you probably saw this with him. I know we show a bunch of different videos, and I'll do my best to show this one for you all as well. You have hydrogen peroxide breaking into water, oxygen, and heat. This is what happens when hydrogen peroxide is poured on a wound. The enzymes in your blood help to break down that hydrogen peroxide, and the bubbling that you see is the oxygen that has been generated. Oxygen is an element, water is a compound. Those are two unique substances compared to hydrogen peroxide. We need oxygen to live. We need water to live. Hydrogen peroxide, if we ingest that, we are going to be in for some serious problems. Those are very different substances, so this would be an example of a chemical change. Finally, we have a crystal being broken apart into small pieces. The crystal has the same composition it started with, it's just in smaller chunks. So that would be an example of a physical change. Physical chemical properties. Physical properties are going to be properties that can change for a substance but don't change the substance's composition. They don't change what makes it up. So you can have qualitative physical properties such as color, and you can have quantitative physical properties such as like its mass. You can also have physical properties like melting point and boiling point. Sorry, that are quantitative. Intensive physical properties are going to be ones that don't change no matter how much of the substance you have. Density would be an example. Melting point would be an example. The color of a substance would be an example. Extensive, however, is dependent on how much of the substance you have. Things like mass or length would be examples, or the amount of energy it takes to heat something up or that has to be released to cool it down. Those are examples of extensive properties. And there I've given you a list of some. Finally, with chemical properties, you're causing it to form something new. You aren't keeping the same composition, chemically speaking, of the substance you started with. Burning, rusting, digesting, growing, those are all examples of chemical properties. So the boiling point of alcohol is just changing it from a liquid to a gas. It's still the alcohol. That would be a physical property. Because it is a numerical value, it would be a quantitative property. And because it does not depend on how much of the substance you have to get that boiling point, it would be considered an intensive property. Sugar fermenting to form alcohol, that is forming something new. That right there tells us that this is going to be a chemical property. And I'm really not going to ask you to qualify chemical properties as qualitative or quantitative, intensive or extensive. We're going to stick with those terms pretty much for the physical properties. A metal wire is able to conduct an electric current. When the metal wire conducts the current, the metal wire itself is not changed. It's just allowing the electrons to move from one point to another. Because of that, it is a physical property. If that was not the case, we would have to constantly rewire our homes and our cars and our schools and computers, and that would not be a good thing. I'm not saying there can't be malfunctions, but if it's working properly, that is a physical property. There was no numerical quantity attached to this property, so that would be a qualitative property. And it does not depend on how much of the material you have, so that would be also an intensive property. Sorry, I clicked on 4 too fast. Platinum is not able to react with oxygen at room temperature, which is part of the reason platinum is added to a lot of jewelry and a lot of metals to help to strengthen them. Because it does not react, what we're showing is the lack of reaction as opposed to whether it would or not. And because we're showing that what it won't react with, although I know it's kind of working backwards, that too is an example of a chemical property. You're showing what would happen if it did react with something, and you're also showing that there are things that it will not change when it's tried to be combined with. Finally, our last one, the mass of a piece of aluminum is 2.38 grams. That would be a physical property. The mass of that object is not going to change the composition of that object. There is a numerical value associated with it, so it is a quantitative property. But this one's going to be extensive because how much you have is dependent on the amount of aluminum that you have present.